Hello everyone, this is Srikanth, working as a assistant professor in electrical department. In this video, I want to discuss about maximum power transfer theorem problem. One problem on maximum power transfer theorem. Here I have a problem. So just read the problem once. Okay. Find the RL value. I need to find out the RL value for the given network below. And what's the condition there? The power is maximum. So I need to find out the RL value when the power is maximum delivered to the load. Okay, that means at RL point you have the maximum power. So we need to find out the RL value. And also find out the maximum power. I need to find out the power and I need to find out the RL value. So I have one circuit. In this circuit I need to find out the RL value as well as power also. Okay. Now for this, what is your statement? Maximum power transfer theorem state that any linear network, the maximum power is delivered to the load when the load resistance is equal to the source resistance. Okay, that means RS equal to RL. This is your condition. If you know the RS value, you will get the RL value. So how will you find the RS value? So you can use any method. Okay, you can use any method and just find out the RS value. To simplify your circuit to like Thevenin circuit or Norton circuit, then you can find out the maximum power transfer theorem is simple. This circuit I want to convert it to Thevenin circuit. What is the Thevenin's theorem statement? That means any network can convert it to single voltage source series with equivalent resistance. That means your voltage source is open circuit voltage, your equivalent resistance is across the load terminal. I need to find out. Okay. So this is your Thevenin's theorem. That means your bilateral network can convert it to voltage source series with resistor. So this is your Thevenin's theorem. From this circuit, if you know the RTH value means nothing but your RL value. So if you find out the RTH value, you will get the RL value. And if you know the VTH value, then you can find out the power value also. So just convert this circuit to, so which 6 volts we have as well as 1, 2, 3, 4 ohms we have. Just convert it to one voltage source series with the resistor. Okay, I'll get the procedure now. For Thevenin's theorem, if you find out the RTH value, for this we have the conditions: voltage source replaced with short circuit and current source replaced with open circuit. So in this circuit I have only voltage source. I will short circuit that voltage source, and across the load terminal I need to find out the RTH value. Just observe here. So voltage source is short circuit and your load resistance is opened. Same circuit which you have. Okay, voltage source as well as load resistance. Voltage source is short circuit, load resistance is open. Okay, at this point, at between like A and B point, I need to find out the equivalent resistance. For this, any series and parallel. So here I have the like a 6 as well as 6. Both are in parallel. Parallel means we have the formula, that is R1 into R2 by R1 plus R2. Okay, then substitute those value here. 6 into 6 by 6 plus 6. We have like 3 ohms. 2 resistors, 6 ohms and 6 ohms converted to single resistor, that is 3 ohms. Now, the 3 ohms as well as 2 ohms, both are in series. Series means 3 plus 2. How much will you get? Like 5 ohms. So 3 ohms as well as 2 ohms converted to single resistor, that is your 5 ohms. Now again, 5 ohms and 5 ohms, both are in parallel. Parallel means again same formula. You can directly write like R by 2, that is 5 by 2, we will get like 2.5 ohms. So your RL value, that means RTH value is 2.5 ohms. So both are in parallel. Parallel means R by 2 will get like 2.5 ohms. So I know the RTH value, nothing but your RL value. Am I right? Now I need to find out like VTH value, that means VOC value. For this we have any statement? Yes, we need to measure the voltage between the load terminal. So I need to open the load terminal. At this point I need to find out the open circuit voltage. So for this I need to open the load terminal. At this point I need to find out the VTH. So your VTH, how will you find out the VTH means across the 5 ohms resistor. Am I right? Across the 5 ohms resistor, how much voltage we have? Same voltage, your open circuit voltage. That means VTH is nothing but V5 ohms. So I need to find out the V5 ohms. So how will you find out the V5 ohms? If I know the current value in this point, at 5 ohms point, then I into your R will get like VTH. So for this, I need to go for the mesh analysis. So how many loops we have? 2 loops we have. That is I1 as well as I2 and write the equation for each loop. I1 into 6 plus 6. That means 12 minus I2. I2 also is we have in this loop. This 6 ohms. That is opposite direction. That means we need to write the minus I2 into 6. Okay. In generally, we write one by one. I1 into 6. So in this point, voltage drop plus I1 minus I2 into 6. So in this point, voltage drop is using loop 1. So I1 minus I2 into 6. In this point, voltage drop is I1 minus I2 into 6 equal to voltage 6 volts. Solve this equation, you will get like I1 into 12 minus I2 into 6 equal to 6. Same as your loop 2. Loop 2, how many resistance we have? So like 2, 5 as well as 6. But 5 ohms we have only one current, that is I2 current. And 2 ohms we have only one current, that is I2 current. But at 6 ohms again reverse. So I2 minus I1. So we will get like I1 minus I1 into 6. So here I will get like minus I1 into 6. But I2 is 6 plus 5 plus 2. How much? 13 ohms. As well as any voltage source or current source? No. So we have 0. So 2 equations, 2 unknown values. Just find out those equations. We will get like I1 is 0.65 as well as I2 is 0.3. So at this point I need to find out the voltage. So for this I know the I value. So which I we have at 5 ohms? I2 value. So what is the I2 value? 0.3 amps. So what is the voltage now? At 5 ohms. So that is 0.3 into 5. So 1.5 volts. So your VTH value is 0.3 into 5. That is 1.5 volts. This is your VTH. We are converted to Thevenin circuit. That is VTH value as well as RTH value. So we'll move to maximum power transfer theorem now. This is your problem. Here given, we need to find out the RL value. So for this, we are using the maximum power transfer theorem. This is your statement for maximum power transfer theorem. Now your circuit is converted to single circuit. So your whole circuit converted to single circuit. That is Vs as well as Rs. That means VTH as well as RTH. When the load resistance is equal to the source resistance. So what is the source resistance value now? That is 0.5 ohms. Nothing but your load resistance value. So what is your load resistance value now? That is 0.5 ohms. Same. So given the problem, so when the maximum power, so at the load point, the maximum power is delivered. That means Rs equal to RL. So we need to find out the RL value. Now RL value is 2.5 ohms. Clear? Again, I need to find out the power also. What is the power formula? Vs squared by 4 into R. So just substitute those values. So what is the Vs value? 1.5 square by 4 into your resistor. That means 2.5 ohms. We'll get like 0.225 watts. So from this circuit, your RL value is 2.5 and your power value is 0.22 watts. So using maximum power transfer theorem, we need to find out the RL value as well as power also. So maximum power also at the load resistance. Maximum power transfer theorem states that any linear network, the maximum power delivered to the load, when load resistance equal to the source resistance. So load resistance equal to the source resistance. Then the maximum power delivered to the load. So this condition, Rs equal to RL. This is your condition. The main circuit, which circuit we have that converted to your Thevenin circuit, will get like RTH value, will get like VTH value. Just substitute those value in this circuit. Then we have the Rs value. So from this Rs value is nothing but your RL value. Why means the maximum power delivered to the load. Okay. So in this condition, we'll get like Rs equal to RL equal to 2.5 ohms. Then we need to find the power also. For power means Vs square. That means source voltage squared by your 4 into R, your resistors. So here I have the Vs value. Vs value is 1.5. So 1.5 square by 4 into your R. R is 2.5. We'll get like 0.22 watts. This is about maximum power transfer theorem. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.